Assalamualaikum and a very good morning. So today we will continue on the final chapter, which is compensator. So in this compensator, I divide this chapter into two parts. The first one is the phase-lag compensator, and the next one is the phase-lag compensator. So this chapter will be used for all the students to solve the given project. Okay, as the introduction, phase-lag compensator. The advantage of the phase-lag compensator is to improve the transient response and also to increase the stability of a closed-loop system. So the compensator transfer function is given as follows. G subscript lit of S equals to K multiplied with S plus ZC over S plus PC, where ZC is greater than 0 or ZC is less than PC. Okay, and normally we can express the transfer function of the phase-lag compensator as follows, where J lit of S equals to K beta multiplied with S plus 1 over T over S plus 1 over beta T for beta less than 1. So in this case, all of you need to develop this G lit of S using this final formula. Okay, next, before we design the phase-lag compensator, you need to know the design specifications first. Okay, this figure shows the Bode plot of the second order closed-loop transfer function, which is in the magnitude only. Okay, so there are several parameters on this Bode plot. First, we have MP. Okay, we have omega P and also omega B. Okay. Basically, there are four types of design specifications. Okay, the first one is the resonant peak, MP. The second one is resonant frequency, omega P. The third one is the bandwidth, omega B. Okay, and if you look at these three specification, all the equation we have the damping ratio. Okay, damping ratio. And the last one also we have a damping ratio. Okay, and next, the last specification is the phase margin, Vm, and also you can note there is a damping ratio. Alright, all the stated specifications above are in your frequency domain. Okay, bandwidth, phase margin, resonant frequency, and so on. And you can notice that they consist of the damping ratio term. So this is the important term that you need to know in designing the phase-lag compensator. So as you know, this damping ratio can be obtained from the time domain specification that you have learned in the chapter number 4. Okay, you can calculate a damping ratio from the overshoot. You can calculate the damping ratio, you can calculate the settling time using the damping ratio information, and also you can calculate the peak time, okay, also using the damping ratio information. So the compensator can be designed based on the given frequency domain and the time domain specifications. Okay, next I will explain the procedure to design the phase-lag compensator. So basically, like a root locus or write a Bode plot, you need to have a procedure. Okay, so the first step in designing the phase-lag, first you need to calculate the bandwidth omega B that is required in fulfilling the design requirements such as overshoot, settling time, and peak time. So you can use this formula omega B. Okay, and it depends on the questions. You can skip this step number 1 if the question doesn't required you to, or doesn't ask you to show the bandwidth. Okay, so basically you can calculate omega b by using the information from the overshoot, okay, settling time, and also the peak time. Step number 2, find the value of gain k for the uncompensated system that fulfills the required steady-state error gain Kp, Kv, and Ka. Otherwise, let the gain k equals to 1. Okay, so this is just a revision from chapter number 4. You can revise again how to calculate the steady-state error from the chapter number 4. Meanwhile, I also give you example. Given a g of s, the system as follows, and it requires you to find k. Okay, it requires you to find k if kp is equals to 3. So how to solve this one? Okay, back to chapter number 4, you can use this formula. Okay, and this kp is equals to 3, and finally you can calculate that k equals to 6. Okay, step number 3, plot the board diagram using the value of k from step number 2 and determine the uncompensated phase margin Vm uncompensated. Okay, so this is basically from the knowledge of the previous chapter, which is the board plot. Okay, so I hope you're already familiar on how to plot the board diagram. So in this case, I suggest that you use the Scilab to plot the board diagram. Okay, step number 4, calculate the compensated phase margin Vm that fulfills the design specifications. Okay, so basically you can know what is the design specification, for example, the overshoot. Okay, then from the overshoot you can calculate the damping ratio. Okay, from the damping ratio you can calculate Vm or Vm compensated. Then step number 5, calculate the additional phase or Vm lead, okay, using this formula. So this is the standard formula, you can just apply this one. Step number 6, okay, find the value of beta using this formula. Okay, basically from step number 5 you already find the Vm lead. Okay, so you already know what is a Vm lead. Then from there you can calculate what is beta. Okay, then actually from beta you can find the k beta, which is the gain of the phase lead compensator. Step number 7, determine the magnitude of the compensator. Okay, from the value of beta from step number 6, okay, you can easily calculate the magnitude of the compensator, which is we call it G lead J omega max in decibel. Step number 8, okay, after we got the value of G lead J omega max, find the omega max on the board diagram, okay, on the magnitude part of the uncompensated system. Okay, you already plot this one from the step number 3. Okay, so how? Okay, from step number 7 you already know the value of G lead J omega max, okay, in decibel. Then in the board diagram, in the board plot, you must put the negative sign, or negative sign is added to indicate that the point is below 0 dB. So you just add this negative sign, okay, to G lead J omega max, and then project a line to this board diagram, and you can find this omega max in the frequency domain part. Okay. Alright, then step number 9, find the value of 1 over T using this formula. Since you already know the omega max and also the beta, and then I hope that you should be no problem to find this 1 over T. Step number 10, construct the phase lead transfer function. Okay, since you already know all the information, okay, you can construct this G lead. And final step number 11, plot the new board diagram and check whether the design requirement is fulfilled or not. Okay. As for the example, I show you example 1 on how to design a phase lead compensator. The question is, design a phase lead compensator such that the system in figure 1 will have 11% overshoot and Kp is equals to 3. So this is the design requirement, 11% overshoot and Kp is equals to 3. Okay. And figure 1 shows the system. Okay, G of S is the system, right? And you need to design a phase lead compensator G lead. Okay, so G lead you actually will put in front of the system. Okay, so this is your G lead. Okay, so please remember, you already learned this in chapter 1. You should know the location of the compensator or the controller basically, which is in front of the system. So the solution. Okay, so there is no requirement on the bandwidth, so you just proceed to step number 2 to find the gain K. So basically you can find K is basically equals to 30,000 for Kp equals to 3. Okay, then using that K equals to 30,000, you can plot the board diagram. Okay, you can use Scilab or you can use MATLAB to plot the board diagram. Okay, so from this board diagram you can find the phi m uncompensated. Okay, so this is the knowledge from the chapter board plot. Okay. Okay, note that the board diagram is plotted using MATLAB software. You can use online software or you can use any software like Scilab. Okay, step number 4, calculate the compensated phase margin. Okay, using this formula that you learned this one in chapter number 4. So you can first calculate the damping ratio, which is equals to 0.5749. Then you input this value in this formula to find the phase margin, 57.47 degree. Then step number 5, calculate the additional phase. Okay, since you already know this value and also this value, then you can find the phi m lead is 41.17 degree. Then step number 6, find the value of beta using this formula. Okay, with beta now is 0.2061, so you can find K beta, which is equals to 4.85. Then step number 7, calculate the G lead J omega max. You just compute this 20 log 1 over square root beta, you can get 6.86 dB. Then step number 8, use the board diagram of uncompensated system and 6.86 dB from step number 7. Okay, you can find the omega max, which is equals to 245 radian per second. And the step number 9, you can calculate 1 over T. Step number 10, you can complete the transfer function of the G lead. Okay. And step number 11, you plot again the board diagram. So the new board diagram, you need to consider the G lead and also the G of S. Okay. And next, check the design requirement. Okay. So if you check, the phase margin has increased from 26.3, okay, in the previous board diagram to 58.5. okay, which is close to the desired design specification that you calculate before, this 57.47. Okay, so this 57.47 is correspond to the 11% overshoot, which actually fulfill your design requirement. Okay, that's all for facelift compensator. Thank you very much.